Hello, and welcome to the introduction for the Grow Beginner Kit for Arduino. My name is Casper Buckby. I work for the UK Electronic Skills Foundation, and this video is intended to get you started with your Grove kits. It's going to be divided up roughly into 4 sections. I'm going to start off by giving you some background about microcontrollers and printed circuit boards. We're then going to look at the real-life Arduino Uno and Grove PCBs to see what's on them and what parts of them we'll use. We're then going to install what's called the Arduino IDE, which is a software we'll need for actually writing our own code. And finally, we'll upload our very first code. To start off, it's worth noting that everything presented in this video is going to be included in the UKESF Grove Kit guide. So that's this PDF document that includes instructions for all the activities you can do with the Grove Kit, as well as step-by-step walkthroughs of the code with explanations. So it's going to be very helpful for you to keep this as a reference as we go forward. And added to that, we need to answer a few questions. The first is we need to think about what a PCB is. So first of all, a PCB stands for printed circuit board. And it's a way for us to use thin metal tracks to connect components together, much like wires, but in a more permanent fashion. So here I've shown the Grove Kit PCB, and we can see that there's a bunch of sensor modules on the sides, a microcontroller in the middle, and other sensor modules on the right. And in fact, these are already pre-connected on the PCB using these small thin metal traces. So I've included this inlay to make that a bit more clear. So here, this is in the design phase of a PCB, where a designer has included 2 square components here and here, as well as some other IC chips on the side. And these gold lines are where the component pins would be soldered onto. And then the green ones are the thin metal traces that connect one pin from one component to the other pin of the other component. So that's exactly what's happening down here. And we'll look at this in a bit more detail soon. But the middle section here is where the microcontroller lives. And this tiny little black dot here is in fact one of these chips here. And all the pins of that have been connected and pre-wired to where they need to go on this Grove Kit for us to be able to do all the activities in the guide. All right, the next question then becomes, well, what is a microcontroller? And a microcontroller is basically nothing but a small computer on what's called an integrated circuit. So this is when I refer to ICs or chips, that's what we mean is this guy here. So this is a IC chip that includes everything that the microcontroller needs. So in this case, it would be a processor, some memory, and then inputs and outputs. And typically what we can interact with via these metal pins are the inputs and outputs to the microcontroller chip. And in this case, we can then use some software to program the microcontroller to do what we want it to. And it's worth noting that this chip alone is the microcontroller. And some of you may have already heard about Arduino Uno boards or other microcontroller types, but in fact, the microcontroller chip is just one of the components on one of these boards. And all the rest is here for us to be able to program and interact with the microcontroller chip. So I'm going to show you and talk about the other components a bit more in section 2 of this video, where we'll look at the real-life Arduino Uno board. But suffice to say that when people refer to microcontrollers, they use the chip and board structure interchangeably. So we call this an Arduino microcontroller, even though technically the microcontroller is just the chip alone. And it's also worth noting that these can come in different form factors. So here we have the same microcontroller in a much smaller package. And now it sits on a board called the Arduino Nano, which is a much smaller Arduino board type. But it does exactly the same thing, just in this case with slightly lower power consumption and power output, because the package itself is smaller, so it can handle slightly less load. All right. The next thing we need to investigate is the concept of an IDE. So IDE, or Integrated Development Environment, is just a fancy word for the software we need to actually program the chip. So this is for the Arduino, it's called the Arduino IDE, and it allows us, or the programmers, to edit, debug, and upload our code to the microcontroller. The software itself, which we'll download in section 3 of this video, will look something like this, where we can type our code here in the central editor and then use some of these buttons to actually upload the code to our GroveKit boards. And it's worth noting that when we use these upload buttons, there's also a button called verify, and what that will do is it'll compile our code. So what does compile mean? Well, here's an example of the compilation process, where we start off by what's called human readable source code. So here's me, I've written this piece of code in a function called setup. I'm trying to set up one of my board pins. I'm using an LED pin and I want to set it as an output. So I've connected an LED to one of my microcontroller pins. Therefore, I'm using this pin mode function to set that pin as an output. And that makes sense to me as a human. I understand what I've written down here. But if I just send this text string to the microcontroller, it's not gonna know what to do. So what we need to do is compile the code. So we go through a compiler, and what the compiler does is it takes our human readable source code and translates it to what's called machine code. Now, the equivalent machine code could look something like this, which is a garbled string of letters and numbers that makes no sense to me, but the microcontroller is happy with the information it's getting from it, and it's gonna implement the version of my human readable code in the machine code language. So that's what we mean by compiling. And that's what we do every time we upload our code. We have our human readable code that we've written, hit the upload button, goes through the compiler onto our chip, and voila, we've programmed our microcontroller. Okay, finally, in order for you to download the necessary software you need, we need to know which operating system you're on. So please have a look for your computer and determine if you're using a Windows, Linux, or Apple Mac machine. And we'll, in section 3 where we download the IDE, you'll need to choose the right download link for the software to be the correct package. And that's it for the background. If something becomes unclear, or you forget something, or you're curious, then there are lots of resources on the Arduino website. There's a wiki for the GroveKit itself. And Google is your friend. There is a large online community for programming microcontrollers. So if you've had a problem, or if you're wondering how to do something, it's guaranteed that 100 other people have too. So when you Google it, you'll find many solutions and troubleshoot tips and just variable declaration structures and much more. So please have a look at those if you get stuck. Let's start by having a look at the original Arduino Uno board, which is this guy right here. And this is not included in the kit itself, this is just for background. But what Arduino has basically done here is they've connected a microcontroller chip, which is this guy right here, to a bunch of other components and PCB traces to be able to interact with this chip via some connectors on the side of the board, via USB to your computer, and also powering the board from a DC power supply. So the way this works is, if I flip the board, you can see, if I get the lighting right, there are some traces going from these pins on the bottom to pins on the microcontroller, which is on the other side of the board. And these PCB traces, or printed circuit board traces, are just thin metal lines. So that's the same thing as you hooking up a wire from point A to point B. And what that achieves is you get pins from the microcontroller out on the sides of the board, so you can physically hook up a wire into these pins. And we have some other components down here which are responsible for making sure that the voltage you provide from this pin is adequate for the microcontroller. So there's some voltage regulation going on here. And then this little black box in the middle is responsible for USB to serial conversion. So that's just to allow the microcontroller here to talk to your computer via the USB. But the main microcontroller is in fact just this chip. And this is the original Arduino Uno. It comes in a form factor like that. There is also a smaller version. So this is called the Arduino Nano. It's exactly the same thing. Again, we have a microcontroller in the middle here, but this time the board is so small that they've actually chucked some of the components on the bottom side of the board. But again, these pins here will be the stuff you connect your signals to, and then there's a micro USB connection for talking with the microcontroller via your computer. Okay, so your kit, however, the Grow Beginner kit for Arduino, is very similar but doesn't quite look the same. So let's have a look at that. So let's put this board aside and let's open this guy. So when you open this, first of all, we see that the printed circuit board is now quite large. So not only do we have a microcontroller here, we also have a bunch of sensors. And the way this is laid out is the middle board here, the big one, is very akin to, as you see, the Arduino Uno. It's slightly different though in that the microcontroller actually is this tiny chip here. And here on the left side we have the USB to serial converter, and this time you also have a micro USB connection to the board itself. Then on the side you get the yellow connectors, which again are the microcontroller pins themselves. And you also have these white connectors, which makes it easier for us to hook up the sensors that we need. So there's a socket and cables that you can use to connect to this. And the rest of this is different sensors on the sides, all hooked up to the microcontroller already via the PCB traces. So the way you use this is on the side you have some compartments with, as I mentioned, some cables that you can use to connect. So these are the ones that plug into the white sockets here. So let's, for example, say we want to use this light, this little LED. We could hook it up from this connector down to the board using this cable. And what you also get on the other side is a USB cable. So this hooks up to your computer, and the micro end hooks up to the connector on the microcontroller itself. So very similar to the Arduino Uno, but in a slightly different form factor. Now you can also bring the board out by pushing these two flaps in and taking the whole PCB out from the package. And they have these nice little feet on the board, so it doesn't touch anything on your desk. And note that the sensor modules here are made such that you can actually push them out. So if you'd like, for example, here to take the temperature and humidity sensor out of this context and plug it into your own projects, there's some tiny holes on the top and the bottom that allows you to actually break out this board. However, for this lab, when you use this kit, I'd recommend keeping everything together for now, because as you can see, if I get the lighting right, for example here, you can see thin traces going along the PCB, and that means that this sensor, which in this case is a buzzer, is already connected to the board. So it's gonna make your life easier to do the projects because there's pretty minimal wiring happening on the board as it is. But don't worry, if you happen to break these out or want to use them separately, that's perfectly fine. Because again, we can just plug in these cables and use them to plug into the main Arduino board in the middle. All right, so that's the introduction to the board. Now let's move on to see how we can get started programming it. To do that, we need to download the Arduino IDE. So on your computer, Google for Arduino IDE, and you should find the first link taking you to the Arduino software page, which is the download page for the latest version of the Arduino IDE, in this case version 1.8.15. And the download options on the right will give you the option for your respective OS. So for me, that's Windows. So I'll click the Windows button. And it'll take you to a prompt where if you want, you can contribute to the Arduino IDE. It's an open source project, in which case you can select the amount and go contribute and download, or you can just hit the just download button and it'll download the executable we need. So if I go to my downloads folder, I have my executable, which I can run. And it'll ask me a couple of questions as per usual. Do I want to allow this app to make changes? I do. And then it'll prompt me for the license agreement. Yes, I agree. It'll ask me which components I want to install. You can keep all of these selected. It's gonna install the software itself, a USB driver, a couple of shortcuts on your desktop for the software, and then just tell it to associate any Arduino files with it. So we hit next, and we can determine the destination folder, which in my case is program files Arduino. That's fine by me. And then this process will take a couple of minutes. Okay, and it's done. So we hit close. We can hide these windows. And you should now be able to find the icon on your desktop, or in this case, I installed it into my program files Arduino folder, so you can find the executable here as well. So let's launch the software. And when you do, you're gonna be presented with an empty sketch window that looks like this. So this is the Arduino IDE. This is where we'll type in our code and use the buttons to upload the code to our software, or our board rather. And a helpful thing to do here is to bring up the guide, because you get a nice little cheat sheet here of the buttons and what they do. And we're also going to follow the instructions here to download some necessary components for this. But in short, the main editor here is where all your code goes. And an Arduino sketch always consists of two sections. There is something called setup and another function called loop. And these are always part of your Arduino sketches, as we'll see in a moment. Then you have a toolbar at the top with the buttons to upload and verify your code, or open new sketches and save old ones. And on the right, there is a looking glass to open the serial monitor, which you'll do in some of the later labs. And you also will be using this IDE to install some libraries, which we'll do in a bit. But first, if we scroll down, we'll see that the first thing we need to do to use the Grove kit, which has the Arduino Lotus board on it, we need to install this driver, this CP2102 USB driver. And this is because the standard Arduino boards that you saw earlier in this video, they come with a different USB driver than the Grove kit. So we need to install specifically the drivers for this kit. And if you hit this link, it's gonna take you to the Silicon Labs download page for the CP2100X USB drivers, where you can hit the Downloads tab and scroll down again to the operating system you're on, which again for me is Windows. So I'm going to download this file. And this time it'll actually download a zip folder. So in your downloads, you're gonna get a CP driver zip. And inside this zip, you need to unzip this. You're going to find the executable to run, which is, in my case, this one. It's the x64 for a 64-bit operating system, which is what most computers are nowadays. So you simply run this application, and I've already done this, and it's complaining that it's in my compressed folder, so I should extract it first. But it's the same procedure as you saw with the Arduino IDE. You hit OK and it installs it on your computer, and that's it. Nothing else to do. If you run into any issues while you do that, because this is a little system dependent, I suggest you copy that number for the driver and then Google something like install CP2100X driver, and let's pretend we're doing it for Windows 7. And you're gonna get a lot of helpful tips, or if people have had trouble before, you'll find how they managed to troubleshoot it. So hopefully that should take you through it. All right, so now that we have the drivers installed, there's a couple other settings we need to do before we are ready to upload code. And they're detailed next here. So in the IDE, we need to select the board we're going to program, which in our case is going to be the Arduino Uno, because it is the Arduino Lotus is compatible with the Arduino Uno. And then we need to select a port. So this is the USB port you hook it up to, and it will be called something like COM a number. So we'll see that in a bit. So in the IDE, to do this, we use the tools dropdown. And by default, I think this should say Arduino Uno for you, but if it doesn't, select from Arduino AVR boards, the Arduino Uno board. You can see that if you're using different microcontrollers, different Arduinos, there's a ton of selections here, but ours is Arduino Uno compatible, so that's what we'll use. And then the second bit is the port. So the port is currently grayed out because I haven't connected the board to my computer. So let me do that. There we go. And if I reselect the tools menu, yep, the port has changed to COM3, and COM3 is in fact the only port I have to select because I only have one board connected. And for you, this number might be different. That's fine. That's just dependent on your computer and what it labels the USB ports. One final note is the programmer should by default be AVR ISP Mark II. And this is correct because we're programming an AVR microcontroller, which is what the Arduino is. But if it's different, make sure you change it to AVR ISP Mark II. And that's it. So those are all the settings we need to do. Now the IDE knows that we have this Arduino compatible board, and it knows which USB port it's connected to. So we're now ready to write or upload our code. But to make it even easier, we've included this UKSF Sixth Formers library. And what a library is a collection of code that's pre-written. There can be examples, there can be tasks, and we can simply import that code into our IDE. So we need to install this library. And we need to go to Sketch, Include Library, and then Manage Libraries to do that. So let's do that. Let's go to Sketch, Include Library, and Manage Libraries. When we do, we should get a pop-up from the library manager. Hopefully. Yep, there we go. And in here, we can search for whatever library we want. So currently it's searching for all the ones. Yeah, there we go. And we can use the search tool to type in a keyword like UKSF, which is probably enough for it to find the library we're looking for. Yeah, there we go. It's taking a bit to load, but you can see that this is the one we want, Sixth Formers, UKSF. And you need to select the version. Always select the latest version, and then just hit the install button and you should be good to go. All right, then we close the library manager, and now we're truly ready to write our code. So in order for me to help get you started, what we're going to do is we're going to use one of the examples that we just installed in the UKSF Sixth Formers library. So to do this, let's go to File and Examples. And in here you have a bunch of different menus for examples. Some of these come with the Arduino IDE, the built-in ones. Some of them are board specific. Some of them are for the Arduino Uno only. And then if you go all the way down, you'll find a section called Examples from Custom Libraries. And this is where the UKSF Sixth Formers library is installed. And here we have in the tutorial section all the tutorials that are that come with this guide. And we're going to click into the first one called LED Blink. And this opens up a new sketch because it's already done for us. So I'll hide the old one and bring up this one. And if we expand the window just a little bit so we see all the code, this is our completed program. And I'm only starting with the completed program because this is just to help you get set up. But when you go through the guide, you should write this code yourself and make sure you understand what all the different parts do. But very briefly, what this code does is it connects an LED to pin 4, or in fact this is already connected on the Grove kit. It's the red LED at the top of the board. And it configures that LED as an output, and then it toggles it on or into a high state and off or into a low state. And it does so with a small delay between each action so that you can see it blink. So this will actually, in this loop function, go around and around and around and just blink the LED on the board indefinitely. And this is just to check basically that our board is working, we can upload code, and everything is fine. So the upload procedure usually is you write the code and as you think is correct, and to verify it, you would click the first button here called verify. And what this will do is it will go through your code and it will compile it for the board and tell you if it finds any errors. And in this case, because I've loaded an example, there shouldn't be any errors. And yep, it's fine. It says done compiling. It gives you some information, like the sketch uses 2% of the program storage space. Okay, that's pretty fine. It's a very small program, so it only uses a little bit of the space. And no errors were given. So that's great. That means we're ready to upload the code. And you can do so by hitting the upload button. But just to note, if there was an error in this code, so let's say I deleted a semicolon by accident, and then I verify, it should now throw an error in red and tell you you've done something horribly wrong. And in this case, it's actually pretty helpful because it tells me it expected a semicolon before the curly bracket token. And this curly bracket here is what closes the loop. And it says we need a semicolon before we do that. And that's why it's throwing there. So sometimes these error messages are helpful. Sometimes they're not so helpful, but hopefully they can catch the errors that you made and pinpoint you to some position in the code where you need to fix things. So let's verify again just to make sure. And it should be all green. Yep, good to go. So we've connected the board, we've verified our code, time to upload. And to do that, you simply hit upload. And when you do, you should see some LEDs blinking on the board. That means it's receiving and transmitting data. And it should turn on our LED, which it's done. Great. Our LED is blinking away. It's stuck in this loop forever, going around and around until we either upload new code or power down the board. And that's all for this introductory video. In the next video, we're going to look at how we can extend and use these modules for our own projects. So I'm going to show you one of my own designs using the modules that are on the Grove kit, but are not included in the module guide. And you should be able to do the same. After you've gone through all the examples, you should be familiar with how all the sensors work and hopefully be able to produce your own code. So thanks for now, and I'll see you in the next video.